Okay, diagram 5 shows the setup of apparatus to investigate the reaction between iron 2 sulfate solution and acidified potassium manganate 7 solution through a transfer of electron at a distance. So when you see this our YouTube question, you already know. We have to know which one is oxidizing agent, which one is reducing agent. So let's do a bit of recap. So which one is oxidizing agent? Oxidizing agent which itself undergo reduction. In Malay is agent pengoksidan mengalami penurunan. So you got KMNO4, K2CR2O7, Cl2, Br2, or any Fe3 plus salt. Okay. Then the other hand, reducing agent, which is undergo oxidation. In Malay is agent penurunan mengalami pengoksidaan. So you got Ki, Kbr, or it can be actually metal like magnesium, aluminum, zinc, and any Fe2 plus salt possible. So in this case, now iron 2 sulfate is FeSO4. So, and acidified potassium manganate 7 solution, which is KMNO4, the chemical name, the chemical formula. So, the ion is, for iron 2 sulfate is iron 2 ion and sulfate ion from acidified potassium manganate 7 solution containing potassium ion and manganate 7 ion. So obviously, the important ion here is the iron 2 ion and the manganate ion. So as you know already, MnO4 negative here will receive electron because reduction, right? Reduction means receive electron, menerima electron. The Fe2 plus dot here will donate electron. We call it menerima electron, membebaskan electron. So it means if you see KMnO4, you know this is already oxidizing agent, agent pengoksidan, undergo reduction, receive electron. So what happens if MnO4 negative receive electron, turn to what ion? Now, with the help of, you know, as acidified, acidified means acidic. It means actually this thing is not pure KMnO4. They mix a little bit of sulfuric acid. Actually, normally they use sulfuric acid. Okay, so inside, actually the whole thing, it means the whole thing contain, other than these two ions, contain a little bit of H plus and SO42 negative. But of course, this ion is not so important because the important one is the hydrogen ion. So this thing, okay, what is the hydrogen ion will help to turn this MnO4 negative to become, and of course, with the help of electron also, okay, acidic, and with the help of electron, okay, will turn MnO4 negative to Mn2 plus. We call it manganate 2 ion. I'm not manganate, sorry, manganese 2 ion. In Malay, it's called ion mangan 2. So again, what is the color of KMnO4 at the beginning? The color is purple. After the should become colorless. Tidak berwarna. Okay, actually, originally got a bit of pink lah. Of course, it's merah jambu, but it's very, very light merah jambu. So we consider as colorless. It's a very, very light pink. Okay, and here, the Fe2 plus, since here is reduction, right side, here is reducing agent undergo oxidation by releasing electron. So the Fe2 plus, what happened? Will release electron, become Fe3 plus, become a more positive charge ion. Of course, any Fe2 plus is green. After reaction become brown. Okay, so we can show you the question A. What's function of this thing? Now, here they put electrode X, electrode Y, and this part they put the reducing agent. This one they put oxidizing agent. So the function of the middle one, you got two uses. One of them you can say to separate the oxidizing agent and reducing agent, untuk memisahkan agent pengoksidan dan agent penurunan. You don't say lah, okay? But I mean you don't say just OA and RA lah. If you want to say that sentence, you say untuk mengasingkan. In Malay is untuk mengasingkan the whole name dan the whole name. If in English, so to separate acidify potassium manganate 7 solution and iron 2 sulfate solution. Or normal, but this one, the most common one is to complete the circuit by allowing the movement of ions. You might not answer what does it mean, okay? So, okay, you know that. Which one undergo oxidation means which one we donate electron, right? So the electron come out from here, okay? Actually, electron flow through the external circuit. It means the electron not flowing this, no. Okay? The electron flow from like this, flow through the external wire. Okay? So from the X to the Y, isn't it? From electron X to electron Y. Now, think carefully. So what happens? For this part, right? If you notice, I got Fe3 plus. Okay? It means at electron X, okay, it will keep forming. It will keep producing a lot of positive charge ions. Okay? A lot of like Fe3 plus. You see, the result will turn from Fe2 plus to Fe3 plus, isn't it? So it keep forming more positive charge. Okay. Meanwhile, same thing. You can imagine this one. You must be. Then I thought this one also positive ion. Yes, but the thing is, there's one difference here. Okay. So the difference is we have to use up actually inside, right? At the beginning, inside contain a lot of these four ions, isn't it? Okay, okay, the most important one is this two ion, correct? But since this is acidified, this is acidic, we also contain this two ion. So what happens is you need to have this H plus ion to turn MnO4 negative to become Mn2 plus. So it means inside the H plus, inside this, the H plus is that you use up. You're getting less and less H plus. So you see, actually this side, now it become more. If you got less H plus, now it's left more like SO2 negative, or more like, the MnO4 negative also. But because the MnO4 negative will turn to Mn2 plus, that's why this doesn't matter. Okay, but for this part, you're getting lesser and lesser H plus. So you left a lot of SO2 negative. So means one side have a lot of positive ion. The other side, you will have a lot of SO2 negative. So what happens? One side crowded with positive, one side crowded with negative. Now imagine if the electron keep moving, right? Now electron move from left to right. So what happens? Imagine electron is not imagine, but electron is negative charge, right? So electron, a lot of electron coming out, let's say. You see, a lot of electron left this area. Isn't it this area even become even more positive, correct? This one here, no more electron, right? Electron loss, no more. Now, in this area, containing a lot of negative charge electron, you can just imagine, got so many electrons. Now got even more negative charge in it. Already it's got sulfate and even this ion. And some more you got negative electron coming up. At one point, Isn't this part is being too negative, and this part is being too positive because no negative. So at one point, right, the problem is the electron will stop moving. Stop moving meaning what happens is the electron cannot flow here anymore. And because two things, this electron started to repel the new electron. Let's say the new electron want to enter here, right? Hey, like in the lift, if got too many people, what happens? They always say you go to the next round. I push you out, okay, you cannot go in because too crowded. Same thing. You notice inside too cramped, too crowded. So the new electron cannot enter. If the electron cannot flow, right, stop, right? Instead, this thing is stop working. Okay, this thing cannot have cannot conduct electricity anymore. Okay, cannot have the free moving electrons. So it stop moving. So what happened? This GG might stuck, right? So it's like here is when the salt bridge come in. The salt bridge is dilute sulfuric acid containing H plus and sulfate ion. Just because I explained this, you understand what's the meaning of this? I don't really understand. Okay, what's the purpose of this? What do you mean by complete circuit? What do you mean by a lot of movement ions? So in this case, what is since here got too many negative, right? So now the H plus will come here. What do you do? H plus is what charge? H plus is positive ion. So what they can do? You know what actually they can do? They can cancel out the charge here. Positive charge can go and neutralize the charge. So that now becoming less positive, less negative, then the electron can continue to flow again and again. If we go again, then here we come again, neutralize again. Same thing for here. Here is too negative, too positive. In a way that actually just now you can also say the electrons are attracted back by this ion. Isn't it? Because this ion is too positive, less people, less negative, less negative, not crowded. That's why they say to electron, you come here. So the direction is not right. It's not right. So in this case, the electron cannot form. So you say in this case, the sulfate ion go and neutralize this positive charge, make it more negative, so that to make sure electron cannot be pulled back by this, so that electron can flow normally, because both sides are being neutralized by this salt bridge. So then only the electron can flow, they only can complete the electrical circuit. If not, the electron will stuck because of this. Understand? Yeah. So just in case you don't know, okay, I have too much, but just to make you understand the concept. Okay. Change of color after 30 minutes for KMnO4, simple, purple to colorless. Oxidation number of Mn in manganate 7 ion. This is MnO4 negative charge. So let's say you don't know what is Mn, right? What is the oxidation number of Mn? So Mn, but you know O is negative 2. You already know, okay? Oxide, right? Oxide is O2 minus 1. So you know that here you got 4O. So you got 4 negative 2. The whole thing is what charge? The whole thing is equals to negative 1. So the Mn you will get what charge? What oxidation number? Negative 8 become positive 8. So negative 1 minus 8, negative 1 plus 8, positive 7. Okay. Half equation. X very simple. Fe2 plus donate 1 electron, become Fe3 plus. Why? Now I teach you the shortcut. Okay. So number one, you must remember this ion. This changes MnO4 negative to Mn2 plus. Manganate 7 ion. In Malay, it's called ion manganate 7. Manganate 7 ion become manganese 2 ion. So I know first from this ion to this ion. Okay. Then you the name, right? Remember the name, I told you, right? Inside also you need to have H plus together. So you need H plus to convert the MnO4 negative to Mn2 plus. Yes, so you have to add H plus. And what happens? This is oxidizing agent. It will receive electrons. So yes, receive electron. Okay. And then if you see left side, right side of Mn. And H and O, the back you H2O. Now it's just a balancing, right? So here's the one. Both sides got 1 Mn. Left side got 4O. So the right side multiply 4. Now, right side got 8 hydrogen. 4 times 2, 8. So now the H plus multiply 8. The charge, okay, so the charge for this, the overall is -1. Here originally is +1, but since you got 8, so means you got +8. The overall is +7. Here overall, I mean not overall, but Mn is +2. Water no charge, neutral, so 0. So the overall +2. So +7 minus what become +2? 7 minus 5 become +2. Or you can say 7 receive the 5 electron, you will get +2. This is the Y half equation, one of the hardest equation. Then the ionic equation, you must have these two, right? What I should do? I write back the half equation first. I write back first. Then I show you same thing. So I copy back. Correct? Then what should I do? Always you look at the electron, is it balanced or not? No, this one is 1, this one is 5. So I have to make balance. For the x, what should I do? The whole thing multiply 5. You see, now it becomes 5 Fe2 plus, 5 Fe3 plus, 5 electron. Then only I write the final answer without including the electron, obviously. Then the whole thing, before arrow, you write, before arrow, you got 1, 2, 3. So I write 5 Fe2 plus MnO4 negative plus 8H plus. After arrow, 1, 2, 3. So you got 5 Fe3 plus Mn2 plus 4H2O. Okay, this is our final answer. Final equation. Describe briefly a chemical test to verify the cation produced in a solution at carbon electrode X. So cation is positive ion. The positive ion produced in X is Fe3 plus. Means how do you test Fe3 plus? You got 4 different methods. You choose one only. Okay, you got 4 different methods. The first method being you can add. Okay, you can add. Either you add NaOH, sodium hydroxide, or you add ammonia solutions, also can. Both you get the same result. You add excess, you add a lot. Then you get brown precipitate form. Because the Fe3 plus, the test, how do we confirm the presence of Fe3 plus? Because these two are alkaline. Alkaline contains hydroxide ion. So when these two react together, you will get the brown precipitate because you got iron 3 hydroxide. Okay, this is number one. You can also write this, or you can write a potassium potassium thiocyanate solution, which you will get blood red solution form. This one you add few drops. Okay. Follow in Malay, follow Malay natrium hydroxide, larutan ammonia, menggunakan perang. So this one is larutan kalium thiocyanate, larutan merah darah terbentuk. Or another one, you just choose one only. This one I give you option, right? Because answer scheme can sometimes it can many possible answers, but you choose the one that you like. Okay, so what you can say, you can use potassium hexacyanate 2, also few drops, then you will get, this one wrong answer already. Have to change. This one is dark blue, sorry. In Malay, you change, menggunakan biru tua. Okay, can? Suggest another substance that can replace iron 2 sulfate solution in diagram 5. So iron 2 sulfate is the reducing agent. Other than Fe2 plus salt, you can add Ki. Kb also can. You can use Ki, KBr, or sulfur dioxide. But I don't recommend sulfur dioxide. So I will say Ki or KBr. The best I will say Ki. Ki very strong. Very strong reducing agent. Adalah agent penurunan yang kuat. Okay.